Any questions?
I have a question on the master set about the slinky being bounced up and down.
Right.
Are you talking like this or like this?
It's like keep bouncing up and down.
Because if it's attached to the wall,
Let me see the wording before I
it
answer.
says slinky bouncing up and down.
Like that.
Okay.
Which question was it?
It's-
Oh, this is, what type of wave is it?
Yeah, because if it's up and down like this, it's one way, but if it's attached to the wall like this. it's a
Yeah,
different
no,
way.
that's what the intent was,
Okay.
like that. Other questions? What I,
Could you do a problem similar to today? I don't know how to do it, but it was similar to the other.
alright, so tuning fork vibrating along vertical tube, third harmonic is heard. Okay, so it's the tubes which are no longer here. Pointed over there, so what
So,
they're missing?
I thought you were talking about that.
Oh, no, not that tube.
the music.
Let's see, so let's make it a fifth harmonic, and let's see, I gave this length, the tube, and the air column. Water column, oh, water, I gave the water and the air.
All right, so we have the tube, water, this is some distance here, and I think I give those two distances, so we'll make that 0.5 meters and 0.7 meters. Number's different from what's in the master set. This is water. This is air. And let's make it the fifth harmonic. And I think the first question was how many wavelengths you need to produce it, what's the wavelength of the sound from the tuning fork, speed of sound based upon the experiment, and the height of the water column. What height will the first height of the water column be the first harmonic. So 256, so we'll make it 512 hertz. All right, so fifth harmonic. First off, we're dealing with a resonance here. Are we gonna have two fixed ends, one fixed, one free, two free ends?
One fixed and one open, it looks like.
Yes. So the fixed end is gonna be down here, the free end is gonna be up there. The first harmonic looks like that, and then you just add a half a wave every time. So that's the first. How many waves is that? Other people can play. So the next harmonics is if I add a half wave every time, how many wavelengths will the next harmonic be?
2/4. 2/4? Oh, I have 3/4.
3/4. And so basically we're gonna be adding one loop every time. And so that would be the third harmonic. And the fifth harmonic. Something like that. So that would be 3/4 of a wavelength, and this would have to be 5/4 of a wavelength. So basically I've got a fifth harmonic here. I've got, this is a node, an anti-node, and going through the typical stunning visual effects. Something like that. In theory, if I hit that harmonic, this point and this point would be silent, and it's the loudest here. I'd like to figure out how to test that one day. So, we have, I forgot, first was, how many wavelengths? Okay, got 5 quarter wavelengths. The next is, what is the actual wavelength? Well, I got 5 quarters of a wavelength, I got 1 1/4 wavelengths crammed into 0.5 meters. Just divide. So from this point of view, lambda is equal to 4/5 L. So that's 4/5 times 0.5. 0.4. In essence, what I'm saying here is that if this distance here is 0.5 meters, from tip to toe, this is 0.4 meters. That would be 0.1 meters. And it makes sense that that's a quarter of a wave, and if my wave is 0.4 meters, then a quarter of it would be 0.1. So the wavelength's 0.4 meters, then the next, I forget what the next thing that they wanted to know was.
The speed of sound based on the
Okay. Well, what's the equation that relates speed, frequency, and wavelength? Yes, it is that. And what is it? You don't remember what the Greek letters are?
No, I don't.
Ah. Black on black, there we go. All right, so E is equal to frequency times the wavelength. That's the basic formula there. I know the frequency because that's gonna be the frequency of the tuning fork. It's telling me how the frequency of the pressure waves. Lambda, we just found. So the speed of the wave would be 512 hertz times 0.4 meters. And we end up with 204.8 units.
meters per second.
And if this were a lab, that would be a very horrible result. Because the speed of sound is about 340 meters per second. Like, I've seen things like that, you know. And then the last part was the length of the water column.
Yes, the height of the water column. Will the first harmonic be?
All right, this one, if I just have the first harmonic, I've got my quarter of a wave. So in essence, I'm gonna start putting water into here, and the water, so when the water's there, I got a fifth harmonic. When the water is there, I've got a third harmonic. When the water is there, I've got a first harmonic. So when the water is to there, I have a first harmonic. And I already know that length, that's 0.1 meters. So what's the length of the water column then?
Or 0.11 meters,
Or 1.1,
1.1, sorry,
something like that.
yeah, not 11.
So it'd have to be, since the whole thing is 1.2 meters, if that's 1.1 meters, it's gotta be 1.1 left. that as no. Alright. The last one, no. With, we talking about electricity.